talk about what you want to learn, and in this case what we're going to learn is balancing equations. So no more hesitations. The first one, I'm gonna take one. You know, I give to my students easy ones and difficult ones, so I'm gonna get 2 of the easy ones and 5 of the difficult ones, so we have a bit of a balance. Perhaps in total we can do like 6, 7 equations. I will start with this one, which is very nice, which is also very common, which is one metal. In this case the metal is magnesium. Can you see well? I'm sure you can. Let me see. Yes, you can see well. It is clear. Magnesium plus hydrochloric acid to give magnesium chloride plus water, I think. No, plus hydrogen. Plus hydrogen. Plus hydrogen. Ooh, wait a second, that 2 is not very nice. You know, I like things to be aesthetic, to be beautiful, to be nice. Okay, so here we got the chemical equation, and this is not balanced. It is not balanced. I can tell you from the very beginning that it is not balanced. First of all, a few things to mention, just like to expand. Magnesium, group 2 in the metals, group 2 in the periodic table. Quite common, very nice metal. And hydrochloric acid, one of the most common acids to use in the laboratory. Okay. Yeah, this is chemistry. Absolutely. Today we're doing chemistry. The reaction produces a salt. This is a salt, not a salt like the one you can eat, but it's a salt because it has a part that is a metal and a part that is not a metal. Okay. And also we produce hydrogen, which, if you remember, hydrogen is a very flammable gas. It is very reactive and is very flammable. I'm just informing my year 9 that now the camera, it is working. Okay. All right. So why this is not balanced? Why this is not balanced, may you think? Because we don't have the same amount of atoms on the left that on the right. Let's count. How many atoms of magnesium do we have here? We have 1. And here we also have 1. Remember, when there is no number, it is 1. We don't need to write 1, we omit it. Okay. How many atoms of hydrogen do we have on the left? 1. But on the right we have 2. You see? No balance. And the same with chlorine. Here we have 1 atom of chlorine, and in here we have 2 atoms of chlorine. So it is not balanced. Now, it is important to understand that we cannot modify numbers there, here. We cannot change these numbers. We cannot touch those numbers. Those numbers is referring to the molecule, and the molecule is the way it is. We cannot change it. What we can do is add factors in front of the compounds and molecules. There is where we can add things. Okay? So where on the left we can add, we can change, so we have more atoms of hydrogen and chlorine. The answer is in here. If I add 1, 2 in front of the hydrochloric acid, this 2 affects to both the atom of hydrogen and the atom of chlorine, to both. So it's multiplying by 2 in here and here. And how much is 1 times 2? It is 2. And how much is 1 times 2? 2. Equally. Now the equation is balance. Okay, now the equation is balance. So that is, this one was one of the easy ones. Easy. This one was easy. Let's take another one. Okay? Let's take another one. And as I mentioned earlier, but I'm not sure if you were in here earlier, balancing equation is a matter of practice. The more you practice, the better you are going to get. Okay, so let's take for example iron plus oxygen. Let's zoom in. The problem with I zoom in is it makes a shadow. It makes a shadow. Iron plus oxygen to give iron oxide. Okay, iron plus oxygen to give iron oxide. Let's see if it is balanced. How many atoms of iron do I have before the chemical reaction? 1. And how many do I have in here? 2. Why? This number refers to that element. This number refers to that element. Always these little numbers, these tiny small numbers, they refer to the atom before the number. Okay? Not after, before. So same with oxygen. In here I have 2 atoms of oxygen. In here I have 3 atoms of oxygen. So clearly it is not balanced. Alright? So what do we do now? Remember, we can add numbers in front of the compounds. Not in the middle, not behind, but in front of. So what do? I can put numbers here, 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 here. Where on the left, I can add more, so I have the same amount of iron. I can put a 2 in here. So now in here, I will have 2 atoms of iron. But then if I try to modify the oxygens, here I have 2 and here I have 3. It's complicated. I need to think about what is the possible combination between 2 and 3. Between 2 and 3. If you think about it, what is the lowest common multiple between 2 and 3? What is the minimum common multiple between 2 and 3? Anyone knows the answer? Does anyone know the answer? A few more seconds. Okay, if nobody knows the answer, the common multiple between 2 and 3 is 6. So what number do I have to put in here so it makes 6? Easy. 2 times 3, that makes 6. And what number do I have to put in here so that makes 6? One number multiplied by 3 gives me 6. 2. So I need to put that 2 in here. So now I have 6 oxygens in both. The only problem now, if you want to call it in that way, it's tiny problem, is that now this 2 also affects the amount of iron. So now I have in here 4 irons. But why am I saying that that's a small problem? Very simple, because I can remove these 2 and add 4 instead, because the iron in here is alone. So it is easier to change it. So look now here I have 4 irons and here I have 4 irons. Now in here I have 6 oxygens and in here I have 6 oxygens. Now this is balanced. The atoms that they are on their own, or the elements that they are on their own, is much easier to balance. So you can leave them for the end. You can leave them at the end of the activity, because it's much easier to balance if they are alone, if they are on their own, that if they are making like a compound. All right, let's do a difficult one. A harder one. I'm looking at the activities that I gave to my year 9 and I'm checking. One difficult one could be, for example, let's do this one. Sodium nitrate decompose into sodium nitrate plus oxygen. This one is slightly more difficult because we have more elements involved, but not that much difficult, okay? This is a clear example, seems like this is a clear example of thermal decomposition. What is thermal decomposition? Is when one compound breaks down because of heat. Because of heat, breaks down into something more simple, something more smaller, okay? Let's see how many atoms of each element do we have at the beginning. So sodium, which is in group 1, we have 1 atom, and here we have 1 atom. Nitrogen, here we have 1. Oxygen, here we have 3, and here we have, how many do we have in here? Anyone knows the answer? How many atoms of oxygen do we have on the right hand side? We have 4. Why do you have 4? Because we have 2 in here and 2 in here. So now we need to think about 3 and 4, but taking into consideration that in here we have them separate. We have 2 and 2. 2 and 2. So what numbers could fit? For example, if I put a 2 in here, let's say that I put a 2 in here, that would multiply everything times 2, and then I would have 6. Then I would have 6. Look, if I put a 2 in here, now is sodium times 2, times 2, times 2. So this is 2, 2, and here now we have 6. How do I balance it now in here? Well, someone will say that, well, you need to put another 2 in here. So it is times 2, times 2. And now we are going to have 4 plus 2. We are going to have 6. Look how easy it was at the end. Let me count it again, because I want to show it looked very long, it looked very difficult, but it's not. Atoms of sodium, 1, 2. Remember, this 2 in here affects everything. Atoms of nitrogen, we have in here 1, 2, and here 1, 2. And then atoms of oxygen. Oxygen was the one that was making this difficult. We have 3, but because we have 2, we have 6. And here we have 2, but times 2 is 4, plus 2, 6. Balance. You see, even the harder one, they're much easier when you are used to do them, okay? All right, we have done a few. Let's do 3 more, okay? But I will speed up a little bit, because what I want is to help the students, but it is the students the one that they need to do it. Let me choose, for example, sodium plus phosphoric acid to give sodium phosphate plus water. Sorry, this got a bit too long in the writing, okay? All right, as I always do, sorry, I like a beautiful arrow. Counting before and after, how much of each do we have? Atoms of sodium, in here we have 1, and here we have 3. This is a 3. I don't know if it is clear, but this is a 3. 3. Oxygen, here we have 5, and here I have 5. Why 5? 1 and 4. 5. And here I have 4 and 1. 5. And hydrogen, here I have 4, and here I have 2. And phosphorus, here we have 1, and phosphorus, here we have 1. So a few things we don't have balance. We don't have balance the sodium, we don't have balance the hydrogen. So the only place on the left where I can put more sodiums is in here. So if in here I have 3, the logical thing is going to be to put a 3 in here. So now I have 3 sodiums. But that is going to affect also the number of oxygen, because now in here I'm going to have 3 oxygens, and here I have 4, so in total I will have now 7 oxygens. And about the hydrogens, here I will have 3 hydrogens and 3, here now I have 6. So now it's not balanced. But it's not that difficult, because look, this one probably we need to leave it. Don't touch it. But if we have now unbalance is hydrogen and oxygen, where do we have hydrogen and oxygen? We have it in here. We have it in the water. So now what we're going to do is we're going to change in water. How do I do it? If you see, we need in here 2 more, well, we need 3 more atoms of oxygen. So if in here I get 3 plus 4, I will make 7. And we need 4 atoms of hydrogen, because in here if I have 4, sorry, if I have, yes, I need 4 more, because here I have 2 and here I have 6. So I need 4 more atoms of hydrogen. If I put a 2 in here, let's see if that changes anything. So now I will have 2. Here we have now 4. But I need 6, so it's a 3. It's a 3. It's a 3. Now I have 6, because this is 3 times 2 is 6. And about the oxygen, now I have in here 3 oxygens and here 4, 7. Now it is balanced. Balance. No idea what happened with these cameras, but leave them to have fun. We are gonna leave it in here. We have marked more than enough. I will share the video with my lovely group of students so they can mark their balancing equations. As I mentioned, this is a difficult topic, lots of practice, more practice a different day. It has been an absolute pleasure. Have a lovely evening. See you guys. Bye bye.